All right, everybody, we're going to talk about irrational numbers and also squares and square roots today. We'll first talk about squaring a number. We've done this earlier this year. We had a couple of buttons on our calculator even that we used for this. But a perfect square is a number that is the square of an integer. So 25 is a perfect square because 5 squared, 5 is an integer, 5 squared is 25. Okay, so what I would really like for you to know are the first 15 perfect squares. So it's really easy to go through those, and you probably know most of them. You're basically going to say what's 1 squared, what's 2 squared, what's 3 squared. Okay, so let's go through them. 1, 4, 9. Okay, so far, 1 squared, 2 squared, 3 squared. 3 squared is 9. 16, 25, 36. You're staying with me now? 6 times 6 is 36. 49, 64, 81, 100, good. 121, 144, 169, 196, and 225. Those would be the first 15 perfect squares, going all the way from 1 squared to 15 squared. Okay, now here's the newer part, square root. Some of you have been asking me about this thing. You've seen it on your calculator or in a problem, and you've thought, what in the world is that? This is a square root sign. Looks like a division sign with a little check mark in the front. It's basically the inverse of squaring a number. So we know that 5 squared is 25. So if we had the number 25 and we wanted to find the square root of 25, that means what number did you square to get 25? So the square root of 25 is 5. So the first 15 perfect square roots are 1 through 15. Okay, so what we're going to be looking at here is more, we definitely need to understand this idea, but we're going to be looking as to how it relates to irrational numbers. Irrational numbers, as far as you have learned so far in your math history, they're pretty hard to come by. There aren't too many numbers that we use that are irrational, okay? If you cannot write it as a fraction, it's irrational. So decimals that never repeat, they never end, they're irrational. So even if I have a repeating decimal, let's say a 3 that keeps repeating, that's rational because I can write that as a fraction. 1/3 is 3 repeating. So that's a rational number. Here's an example of a decimal that never repeats or terminates. Okay? So let's say, well, sorry about that. Here we go. Well, for some reason my pen does not want to come on. There we go. All right, so let's say that we have a decimal and we have 0, 1, then we have 0, 1, 1, and then we have 0, 1, 1, 1. You see a pattern, right? And this is going to continue on and on forever. But it's really not a repeat. It's not the same thing over and over again. It's just a pattern that keeps going. So this would be considered an irrational number. Pi would be an irrational number because pi, thank you, pi never ends. It never terminates, and it doesn't show a repeat. There's one other thing that's irrational for us, and that's the square root of a non-perfect square. So if you have, let's say, the square root of 8, 8's not a perfect square. So if you saw this in the problem and you were asked, is it rational or irrational, you would say that it's irrational. So how do we find the square root of a non-perfect square or estimate it? We simply look to see, what we're going to be doing anyway, is looking to see what two perfect squares is it between. This is between 4, which is 2 squared, and 9, which is 3 squared. So the estimate of the square root of 8 would be somewhere between 2 and 3. So that's actually what we would put on the answer line, 2, 3. All right, let's get some practice in.